My dear children, warm welcome to TSRJC educational channel. My heartfelt congratulations to everyone for crossing the SSC hurdle. All of you qualified in SSC examinations with a good score. Now it is the aspiration of several 10th qualified students to get a seat in Telangana government residential junior colleges. It's not a big task to get a seat in any government residential junior college if you have a little plan of action. Today let us discuss chemical reactions chapter, how the chemical changes will take place, what type of questions will be asked from this chapter. Let us discuss. Whoever set the paper, at least 5 to 8 questions will appear from this chapter. So it's a very important chapter for getting a seat in any residential junior college. See, the chemical reactions start in our life from the time we wake up from the bed. In our day-to-day life activities, we will see several chemical changes. So, how the chemical changes or chemical reactions will take place, how to calculate the reactions, how to calculate different products or reactants in the chemical changes. Let us see. So, elements and classification of matter is the starting concept of chemical reactions. You know very well that solids, liquids and gases we will see in our surroundings. So, all the matter in our day-to-day life comprises of in these 3 states mainly. Of course, another state is also there, colloidal state. Now, in this chapter, let us discuss different states of matter and how the chemical reactions will take place. See, solids, liquids and gases, whatever the substance is, it consists of atoms or molecules. If the molecules or atoms are binded together very closely, it is called solid, and if the atoms loosely binded, then it is called liquid state. If the molecules and atoms are dispersed in the medium, it is called gas. So, these 3 states are interchangeable. Solids on heating, they will convert into liquid state, and the liquids they will convert into solid state by freezing. Similarly, the liquids by evaporating or by heating, they convert into gaseous state. So, matter consists of different varieties of substances. What is pure, what is impure? What do you mean by pure matter? Purity means if the substance contains only the same variety of subatomic minute particles, it is called pure. But we don't see purest substance in our day-to-day life, because almost all elements contact with other elements and they will form different varieties of compounds. So, pure substance will be the compounds or the elements. Either compounds or elements, they will contain the same variety of atoms or molecules. The remaining substances, they are called mixtures. Again, mixtures means homogeneous and heterogeneous mixtures. Homogeneous mixtures, mostly the solutions. Almost all solutions, alloys are treated as homogeneous solutions or homogeneous mixtures. Heterogeneous means the uniformity will not be seen in the substance. The particles are not alike. Different particles, different variety of particles, different size of particles we will see in the mixture. Such substances like sand, dirt, these are called heterogeneous mixtures. Now, already we learnt about physical changes and chemical changes in your lower classes. What is a physical change? It is a physical one, by means it is a temporary change. If a solid substance convert into liquid, or liquid convert into gas, or the gas convert into liquid state or solid state again, it is called a physical change. The best example is ice. When you heat ice, it will convert into water. So, it is called liquefaction. When the water vapor condense into water, it is also a physical change. What about chemical changes? The chemical changes are permanent one. Once the chemical change occurs or happens, we will not get the previous substances. When a chemical change happens, we will get a new compound due to the substances participate in chemical change. Generally, compounds are made up of different varieties of elements. One or two elements combined together, one or many elements combined together to form different compounds. For example, if we heat sugar in a hot glass test tube, it will char into carbon, because sugar consists of three varieties of elements, namely carbon, hydrogen and oxygen. When hydrogen and oxygen comes out during combustion of sugar particles, the remaining charred material carbon can be seen in the test tube. It is a chemical process. With that charred carbon, we will not get the sugar particles again. The taste, the texture, the crystal state, everything will lost by sugar particles. Now, the combustion reactions will be seen in our day-to-day life regularly. See, in this chart, wood is burning and we will get coal. When you heat a metal piece, it will not combust, but firewood or phosphorus like substances, they will burn and they will convert into different varieties of compounds. Discovery of modern elements. Antoine Lavoisier is treated as father of modern chemistry because he invented and he showed a path to all the scientists to find several elements from our nature, from our surroundings. Lavoisier mainly did some combustion reactions. With the combustion reactions, he concluded that every substance reacts with oxygen, maybe the element or another compound, it will react with oxygen and combust, then it will convert into some other compound. With this concept, so far we found 89 naturally occurring elements and 23 short-lived radioactive elements. Totally, by today, we know about 114 elements. All the elements are made up of the tiniest particles, which are called atoms. Lavoisier heated mercury in presence of charcoal and he got mercuric oxide. During that combustion reaction, mercuric oxide formation, he calculated how much mercury combined with how much oxygen. When the mercuric oxide is decomposed, the same quantity of mercury and oxygen were separated. By this, he understood the substances, whatever are formed in the nature, the compounds or new substances, they will form within the nature. So, during a chemical process, during the formation of a new compound, only the existing atoms react together. There will be no intervene of any external substance. That is why we cannot measure excess quantity of substances during chemical process. Whatever the mass of the reactants, that will be same for the products. So, mass of reactants and mass of products will always constant and same. It is called law of conservation of mass. Later, Priestley, a prominent chemist, produced oxygen gas by exposing mercuric oxide to sunlight. So, Lavoisier, Priestley is the founder of oxygen. With the invention of that oxygen element, the scientists started to find new elements. As we discussed earlier, there are 112 elements which are known so far, and 2 more elements are there, but we do not know the physical and chemical properties thoroughly. That is why we deal with 112 elements. The compound or substance in which the element was discovered. The compound means the elements, 2 or more elements combined together to make such compound. An usual or identifying property of the element by virtue of places, by virtue of cities and countries where the elements found. Okay. So, we named all these elements according to the following criteria. The element were abundantly available. Basing on that place, we gave names to the elements. And some elements were named after the famous scientists. And Greek scientists studied the chemicals thoroughly. So, basing on Greek mythology, several elements were named after some goddesses or the planets. For example, Mercury. Mercury is a planet. Mercury is a substance we know very well from very olden days. So, Mercury is an element. It is named after Mercury because of its appearance. Some astronomical objects also considered to name the elements. Here are some of the symbols Dalton used for atoms. So, to mention the atoms, to denote the atoms, in olden days, like Dalton, other scientists gave some symbolic representations to the substances. Ammonia, gold, zinc, sulfuric acid, etc. They gave symbols. Nowadays, we are using the molecular formula. Let us discuss it later. The earth is comprised of mainly the aluminum, iron, oxygen and silicon. In earth crust, almost 88% of elements appear in our earth crust. Water on the surface and in the air as clouds and fog is made up of hydrogen and oxygen. So, water is the essential substance for a living being. Water is also a compound, it is a chemical, it is made up of two elements called oxygen and hydrogen. So, atomic theory was postulated by Dalton. Dalton postulated some theories. Every element is composed of tiny particles called atom. How they deduced this tiny particle? Dalton used a chisel and grinded the substances. Almost all available substances he grinded to get the tiniest particles. He called it as atoma. So, every element is composed of tiny particle called atom. All atoms of given elements are identical. Atoms of different elements have different properties. So, every element has unique and same varieties of particles except isotopes. Let us discuss about isotopes at the end of this session. Atoms of an element are not changed into atoms of any other element or any other chemical substance due to any type of chemical process. Whatever chemical process you adopt to atoms, they will not change their structure. So, atom is the building block for any substance. So, we can definitely confidently say that all the substances which we are seeing are made up of the building blocks called atoms. Compounds are formed when atoms of more than one element combine together. Of course, ozone is an exemption. Ozone is a compound. We consider ozone as a compound, but it is also an element because it consists of only one variety of atoms called oxygen atoms. So, Dalton postulated some physical phenomena, and from those physical phenomena he deduced the law of constant proportionality or constant composition. Any given compound always consists of the same atoms and the same ratio of atoms. For example, water always consists of oxygen and hydrogen, already we discussed, and it is always consists of 89% oxygen by virtue of mass and 11% of hydrogen by virtue of mass. When you measure the mass of hydrogen, mass of oxygen in water, the ratio of oxygen and hydrogen in water molecules or water substance is in 89:11. The second law of conservation of mass. The total mass of materials before and after a chemical process must be the same. No new substance will be added during a chemical process. If we combine 89 grams of oxygen with 11 grams of hydrogen under the appropriate conditions, then exactly 100 grams of water will form. Another law of multiple proportions. If two elements combine to form more than one compound, for example, carbon reacts with oxygen to form carbon dioxide and also carbon monoxide. If the ratio of oxygen and carbon changes, we will get different varieties of compounds, namely carbon dioxide or carbon monoxide. So, if we measure the ratio of masses of carbon and oxygen in carbon dioxide and carbon monoxide, they will not be same. So, the ratio of oxygen required to form carbon dioxide is different to form carbon monoxide. Similarly, water and hydrogen peroxide, the example is given. So, your questions will be asked in these areas. What will be the ratio of oxygen and hydrogen in hydrogen peroxide? See here, 7.9 grams of oxygen combines with 1 gram of hydrogen to form hydrogen peroxide. Sorry, hydrogen monoxide, it is water. Whereas, to form hydrogen peroxide, we require 15.8 grams of mass of oxygen and 1 gram of hydrogen. The same mass of oxygen, the same mass of hydrogen combines with different masses of oxygen to form hydrogen peroxide or hydrogen monoxide or water. This is called law of multiple proportionality. Now, let us discuss the modern atomic theory. Why we should discuss atomic theory? To understand the chemical reactions. The chemical reaction will take place for a specific purpose. Every element wants to get a stable state. To get the stable state, the chemical reaction takes place among the elements and also among the molecules. Also, molecules and elements may combine to get stability. There are about 14 common elements which were given the English alphabet, like hydrogen, carbon, nitrogen, phosphorus, vanadium, sulfur, wolfnium, like that. So, out of 26 alphabet in English, only 14 letters are taken. Why don't we take the remaining 12 letters to name different elements? See, M means a metal. Already in those days, the scientists widely used some alphabets like M, X, Z. These alphabets were used for different specific purposes. So, we couldn't give those single letter symbol to the elements. Other than these 14 out of 112 elements, 98 elements have given two-lettered symbols like Hg, Na, Mo, like that. Hg means hydrogenum, Mo molybdenum. So, two letters of English alphabet are taken to mention the symbol for elements. Why we have to take the symbols? In the previous slide, we have seen the scientists used to give symbolic representations to denote sulfuric acid or zinc, gold, like that. Day after day, as time is going, several scientists invented enormous number of compounds and many number of elements. So, it is not possible to remember the symbols like pictures which we have seen in the previous slide. So, they felt it is better to give alphabetical symbols to the elements. In this process, 14 alphabets were used to give symbols to 14 elements. The remaining elements got different varieties of symbols. Some elements have symbols from their Latin names. Already I mentioned hydrogenum, natrium. Natrium means sodium. Why can't we give S to sodium? Sulfur is the previous element. Sulfur was found earlier than sodium. So, sulfur is named or symbolized with S, letter S. So, we cannot give the same alphabet S to sodium. So, they searched an alternate way. Like that, they took Latin names. 10 of the elements have symbols from their Latin or German names. Nowadays, the symbols were given after the names of prominent scientists and the places. Now, let us discuss about the molecules, how the molecules, compounds, all these will form. A molecule is a particle. Molecule is a particle that is composed of two or more atoms. Already we discussed. In nature, we come across the molecules, not the atoms. Atoms have no stability except very few atoms like inert gas elements atoms. Helium, argon, krypton, these are considered as inert gases because they will not participate in any chemical process. It is very difficult to make a chemical reaction with these inert gas elements. Except those inert gas elements, all the atoms are unstable and they will try to combine with any other atom to form a compound. Now, what are the isotopes? Already I mentioned isotope. Isotopes are the atoms of an element with identical chemical properties but different masses due to difference in the number of neutrons. So, isotopes and atomic mass, these things we will discuss when we deal with atomic structure. For this chapter, we must understand a little bit about isotopes. Isotopes means the atoms of the same element, they will have different atomic masses. That means the number of neutrons will change. In the beginning, I told every element will possess unique varieties of atoms. All the atoms in an element are unique in nature, but here is the exemption. There are isotopes in almost all elements. Hydrogen is having 3 isotopes, carbon is having 2 isotopes. So, many elements are having different isotopes. So, isotopic atoms are not alike because of the neutron number. The atomic mass of an element is the average of all the atomic masses of those isotopes. Now, how to calculate the atomic mass? If all the atoms consist same atomic mass, we can say the fixed atomic mass. But most of the times, the elements consist of isotopes with a different mass number. So, to deduce the atomic mass of such atoms, we consider the average mass of different isotopes. In isotopes, contribution is determined by relative abundance. So, what type of isotopes abundantly available, we will consider in a large quantity. Which isotopes are less in number, we will not consider such masses to calculate the atomic mass. Now, carbon is assigned an atomic mass of 12 grams. That means the atomic mass of carbon is 12. It is called 1 unit, atomic mass unit. We represent it is in shortcut way AMU. So, AMU of carbon is 12. Basing on this atomic mass of carbon, we calculated the atomic masses of different elements. In the beginning, to calculate the atomic masses, hydrogen was taken into consideration. Later, carbon is widely accepted by all the scientists in the world. So, carbon 12 is considered to calculate the atomic masses of different atoms of different elements. The number of protons and neutrons in an atom is its mass number. Atomic numbers are whole numbers. All the atomic numbers. What are the atomic numbers? Hydrogen 1, helium 2, like that we give numbers. These are the whole numbers. We don't have any atom with 1.5 or 1.2 like that. Mass numbers are also whole numbers. The atomic mass is not a whole number. Mass number is a whole number. Why? Because the mass of any atom is due to the neutrons and the protons. The number of neutrons and the number of protons is a whole number. How many protons are present in the atom? How many neutrons are present in the atom? Both are whole numbers, so we will get mass number as whole number, but atomic mass is the average mass of all the isotopes occur in nature. That is why we discussed about isotopes. Now, let us discuss valency. It is very important and it is the origin word for chemical reactions. Without knowing or without understanding valency and valency number, we cannot understand any chemical reaction. Valency of an element is its definite combining capacity that determines the atomicity of its molecules. Different atoms have different valencies. Simply saying, we can consider a best example from our day-to-day life. The valency number is the combining capacity or atomicity. How many atoms will participate in chemical process during formation of a molecule. See, to cook rice, what your mother do? She will take 1 proportion of rice and 2 proportions of water. So, to prepare rice, always we have to take 2 proportions of water and 1 proportion of rice. To prepare different dishes, we add different substances like salt, pepper, chili powder in a definite ratio. If you add more salt to any dish, it will not be tasty. So, the salt required to make a dish very tasty is a fixed one. For different dishes, it will vary. So, atomicity also in the same way, it will change from one atom to other atom. Also, when that atom combines with any other atom, again it shows different number of atomicities sometimes. For example, sulfur shows the atomicity 2 and also 8. Similarly, phosphorus shows atomicity 3 in some reactions, and during some other chemical process it will show the atomicity 5. It is called pentavalent. The valency number, basing on valency number, we will give a nickname to the atoms: monoatomic, monoatomicity, biatomicity, triatomicity, tetraatomicity, or tetravalent, trivalent, pentavalent, hexavalent. No atom will not have the atomicity more than 8. Even 8 also atomicity will not exist. We will discuss the reason for the atomicities 1 to 7 only in atomic structure in depth. The valency is the combining capacity number. To represent an atom symbolically, we write the symbol atomic mass on the left hand superscript position and atomic number in the subscript position. The charge, if any, is there, that will be represented on right side exponential place. See, this is one example. Hydrogen. Hydrogen is having one proton and one electron. The number of neutrons present in hydrogen is 0. But if any hydrogen atom possesses a neutron, it is treated as isotope. Some hydrogen atoms consist of one neutron or two neutrons. So, we will see three isotopes for hydrogen, namely H1, H2, H3. What is that 1, 2, 3? It is mass number. So, on the exponential position, we showed the mass number. H1 is normal hydrogen atom. If it is 2, it is an isotope. If it is 3, it is another isotope, like that. Now, sodium. The mass number of sodium is 23 because there are 12 neutrons in sodium nucleus and 11 protons. We will not consider the electron number in measuring the mass because the mass of electron is apparently low. Almost 1080 electrons mass is equal to the mass of one proton. So far we know only 114 elements. The last highest atomic number element will possess only 114 electrons. It is much more less than the mass of a proton. So, we will not consider the mass of electrons during calculating the mass of any atom. Now, the elements will be classified into different ways. See, from these concepts we will get the questions. Please try to understand the sentence thoroughly. From the sentences only we will get the questions in the entrance examinations. Any competitive exam, all the questions will be prepared with these concepts only. Right. Elements that are usually solids at room temperature, most elements are metals. Metals have specific qualities and nature properties like conductivity of electricity, malleability, ductility, like that. Non-metallic elements in the upper right corner of the periodic table. And apart from metals and non-metals, there are metalloids. Metalloids are the elements which are changing their metallic property into non-metallic property. That means they do not have the fixed metallic property. For example, mercury. Metal means it is a solid which will make some sound and which can be malleable or ductile. We can make the wires of the metals. Mercury is at room temperature, it appears to be a liquid, but it is considered as metal. So, some elements which are not having specific metallic properties or specific non-metallic properties, those are called metalloids. Now, let us come to the part, the main purpose of this chapter, describing a chemical reaction, calculations, how to make sums in chemical reactions, what type of questions will be asked in this chapter. Let us discuss one after one. In a chemical reaction, the reactants are written at the left hand side and the products on the right hand side. They will be separated with arrow mark as shown here. See, reactants and products. When a chemical process has taken place, how much quantity of one element, how much mass of one element reacted with how much mass of another element, we will calculate. So, this number is called coefficient. In this reaction, to understand it very clearly, two molecules of hydrogen reacted with one molecule of oxygen to form two molecules of water. రెండు భాగాలు లేదా రెండు అణువుల హైడ్రోజన్ ఒక అణువు ఆక్సిజన్తో చర్య జరపడం వల్ల రెండు అణువుల నీరు ఏర్పడింది. సో దీస్ two substances, hydrogen and oxygen, these are called reactants, and water is the product from this reaction. During writing a chemical reaction or chemical equation, we use these symbols. In the examination, if they give this symbol, what I exposed now, this arrow mark, left arrow and right arrow together. So, what the symbol represent, they will ask in the question. It is called a reversible reaction. If a reaction is indicated, the reactants and products are separated with a single arrow like this, it is only a forward reaction. We will get yieldings, that means products. So, basing on these symbols, one question may be asked in the competitive exams. After writing the equation, we represent the nature of the molecule or nature of the substance. Here, I mean the substance means maybe the reactants or the products. If the reactant is in solid state, we represent the solid substance with S. This is L, liquids, gases. So, in what state the reaction is taking place, in what state one molecule or atom is reacting with another molecule or atom, that will be represented like this. AQ means aqua, aqueous state in presence of water. అంటే నీటిలో కరిగినటువంటి జలద్రావణాల మధ్య జరిగే reactions. In solutions, whatever reactions take place, those are called aqueous reactions, aqua reactions. Right. Now, the catalyst will be denoted separately on the arrow mark. If we write a name like molybdenum or phosphorus pentoxide, it is known as catalyst. What is a catalyst? In some reactions, when the reactants form products, the reaction will not continue very smoothly. The reaction may be slow, or most of the times some reactions will not happen unless we give some external pressure or external energy. Here, catalyst acts as an external agent to contribute the reaction. Vanadium pentoxide is a well-known catalyst. It is used to prepare ammonia. During preparation of ammonia or getting ammonia in an abundant way in an industry, we use vanadium. Without using catalyst vanadium pentoxide, it is very difficult to get ammonia cheaply. Right. Now, heat reactions. This delta symbol is there. This delta symbol, if we put the delta symbol on the arrow mark, it represents heat reaction. If delta symbol is inverted, the heat is going in an opposite way. If delta symbol is vertical, the reactants taking some heat energy to form products. If the delta symbol is inverted above the arrow, it represents the products will convert into reactants again when they are heated or heat energy is given. That means, when the products convert into reactants, it is a reversal change. So, it is called reversible reaction. Already I told here, reversible reaction will be represented with these two arrows. It is called forward reaction, right hand side, and this is backward reaction. Backward reaction means the reversible reaction, the products will again convert into reactants. In the beginning I told, once the molecule is formed, in a ordinary way it cannot be converted into its original shape. Definitely it is true, but most of the times the products form the reactants. Water, when you electrolyze water, we get hydrogen and oxygen. If you burn hydrogen and oxygen, hydrogen burns or combusts in presence of oxygen to form water. When you electrolyze water, water molecule dissociate into oxygen and hydrogen. So, this is the catalyst. A catalyst is a substance which speeds up or which controls the reaction and which comfortably. A catalyst is neither a reactant nor a product. It will not participate in any chemical reaction. It will be as is during a chemical process. Of course, the texture or the state or the crystalline structure will change sometimes. After happening a chemical reaction, how to represent the chemical reaction in an equation way or in a word format? By making a full-fledged sentence, we can explain the reaction. See here, to write a word equation, write the names of the reactants and products in a sentence form. That means, two molecules of hydrogen reacted with one molecule of oxygen to form two molecules of hydrogen monoxide or water. This is a word format. The same word format will be represented in the form of equation. Why we should write equations? It is very difficult to write the words, sentences for all the reactions. It is a lengthy process and also a time taking process. That is why we give symbols to the elements, and using valency numbers we write the molecular formulae by using molecular formulae, we write the equation like this. If we do not use the coefficient 2 here, what happens? If 2 is not written here, one molecule of hydrogen reacts with one molecule of hydrogen to form one molecule of water, which is absolutely wrong. It will not happen like that. Already we discussed, to prepare rice, boiled rice, we require 2 ratios of water for 1 ratio of rice. In the same way, 2 molecules are necessary to form water molecule. So, word equations and chemical equations, mathematical equation, it is sometimes known as mathematical equation also. See another example, sodium. The state of sodium atoms are denoted here. Solid state sodium reacted with liquid state water molecules to form sodium hydroxide. Sodium hydroxide always forms in aqua region. In presence of water only, sodium hydroxide will form. During this process, we will get the gaseous substance hydrogen. So, it is denoted with G. Now, another example, sulfuric acid H2SO4 in aqua state reacts with barium chloride BaCl2 in aqua state to give barium sulfate and hydrochloric acid. So, aqueous sulfuric acid and aqueous barium chloride react to form solid barium sulfate and aqueous hydrochloric acid as shown in this figure. So, there are other examples. Iron hydrate forms iron oxide and water. Hydrochloric acid reacts with sodium hydrocarbonate or sodium bicarbonate to form sodium chloride. Okay. Thank you.